Example 20 on pipe friction in turbulent flow. Oil of specific gravity 0.85 with an absolute viscosity of 0.0056 Pascal second flows in a 150 mm diameter pipe having absolute roughness of 0.9 mm. So first question, above what flow rate in liters per second will this pipe behave as a fully rough pipe? And below what flow rate will it behave as a smooth pipe? So for part A, the pipe behaves as fully rough if the thickness of viscous sublayer is less than absolute roughness over 14. So that's the condition. Or absolute thickness of nominal viscous sublayer is less than E over 14. So the Reynolds number is equal to diameter 0.15, mean velocity which is 4q over pi diameter square, density which is specific gravity 0.85 times 1000, so 850, divided by 0.0056 which is the viscosity. So in terms of Q, the Reynolds number is 1288397 of Q. Formula for viscous sublayer, nominal thickness of viscous sublayer is 14.14 times diameter 150 over Reynolds number square root of F. So from here we can compute Q square root of F should be greater than 0.02561. Then for fully rough pipe, to solve for friction factor, 1 over square root of F equals 2 log of 3.7 over relative roughness E over D. 1 over square root of 7 equals 2 log 3.7 over E absolute roughness over diameter is 0.9, absolute roughness, diameter 150. So from here we can solve for F. 0.032116, substitute into this equation here. So Q times 0.032, square root of 0.032116 must be greater than 0.02561. So Q should be greater than this value, 0.1429 cubic meter per second, so that the pipe behaves as fully rough. So Q should be greater than 142.9 liters per second. Then in the second question, at below what flow rate will it behave as smooth pipe? The pipe behaves as smooth pipe if the nominal thickness of viscous sublayer is greater than the absolute roughness. So that's the condition. If nominal thickness of viscous sublayer is greater than the absolute roughness. So 14.14 times diameter 150 over Reynolds number square root of F should be greater than 0.9. So Q square root of F must be less than 0.001829. Then for smooth pipe, the formula in computing for F is 1 over square root of F equals 2 log Reynolds number square root of F over 2.51. So 1 over square root of F equals 2 log Reynolds number is 1288397 Q, then square root of F over 2.51. Since Q square root of F is 0.001829, so 1 over square root of F equals 2 log of 1288397 times 0.001829 from this equation here over 2.51. So that means F can now be solved for smooth pipe 0.02829. Then substitute into this equation here, Q square root of 0.02829 must be less than 0.001829. So we can now solve Q. Q should be less than 0.01087 cubic meter per second, or Q should be below 10.87 liters per second. So that's it. I hope you follow the solution and the conditions for a pipe to behave as fully rough and a pipe to behave as smooth pipe.